Hello everyone, my name is Andrei. I'm working as a software engineer at JetBrans, mostly on C# language support in V# and Rider. And today I'll talk about nullable reference types and what problems you might encounter when adopting them on large code bases and how to overcome these difficulties. But first, let me briefly introduce the feature, just 2 or 3 minutes, because maybe some of you didn't have a chance to try it yet. So prior to C#8, you might add a following class named person with first, last, middle name, and birthday. And for birthday, I used nullable struct, which means that the value might be absent, and I have to check whether it's there or not by using hasValue property, and access it explicitly by using .value property, or combine the two by using conditional access. But with reference types, I didn't have such luxury, and whenever I had to use them, I had to wonder whether some of them might contain null values or not. And most of them not, I ended up checking usages of these types to find out whether someone else checks them for null, checking usages of constructors to find out where the values come from. And sometimes I ended up in some external API requests or database reads, so I didn't know exactly whether they can contain nulls or not. And with C#8, I now can annotate my reference types just with the same syntax I use for structs with question mark after the type to tell the compiler and everyone else who will be reading this code that first and last name are mandatory for any person and middle name is optional and can be set to null. And now if I use these properties, for example, to write this toString method and print the person's first name and the first letters of their middle and last name, the compiler is able to tell me that I'm using the middle name property without checking it first, and it might contain a null value and result in a null reference exception. So it emits a warning there. And you might wonder whether it affects performance or not, and whether you still get the null reference exception if you ignore this warning. So to find this out, we'll need to check the intermediate language generated for this method. Don't worry if you don't understand what's going on there. There are just 2 relevant bits there when we access the first letter of the middle name and the last name properties. And you can see that they're exactly the same 3 instructions. And so one of them is nullable, one of them isn't. So there is no performance impact on your code. And if you choose to ignore this warning, you will end up with exactly the same null reference exception as before. So it's up to me to fix this warning, for example, by adding conditional access there. And that's almost everything, at least how this feature is usually presented. But according to the compiler's team own estimate, as of last summer, they invested about 15 dev years into this feature, and it's still going on. They still add new features to it. So let's figure out what else is on the table. First of all, annotations aren't enough. For example, here, I'm dereferencing a nullable parameter, and I obviously should have a warning there about possible null reference exception. But maybe I've already checked it for null, and assigned something different to it. And in this case, the compiler does something known as data flow analysis, and it basically inspects every expression in your program and figures out which variables can hold null values and which can't at every step of your program. Actually, you can access this information by hovering the mouse over some variable, and the compiler will tell you if you hover over the parameter inside the if statement that it may be null there, but it is definitely not null after the if statement because either it wasn't null originally or you assigned something different to it. So it's safe to dereference, and the compiler allows it. And event type inference is affected. For example, here I have a method called choose1 that based on some condition returns one of the variables I've passed in. And if one of the variables I've passed in is nullable, it's not safe to dereference the result of this method, which looks pretty simple, but I really admire how much thought the compiler team put into this feature because they had to wonder about composite generics, different type parameter variants, and so on. And actually, as the compiler does its flow analysis, it uses the enhanced variable state to improve the type inference. So if I assign something else to the nullable variable and it's now definitely not null, the compiler allows me to dereference the result of this method without any warnings. And this is something that couldn't be achieved with nullable structs because nullable structs are a separate type. And in order to maintain backward compatibility, the compiler is forced to infer the nullable int type for the result of this method, and it will force me to dereference it by using special property and work about it. So to sum it up, nullable reference types are exactly the same types as before, just with an additional bit of information. It's not a special type. You can use them just as usual, and they will only result in compile time warnings. There will be no runtime checks as with nullable.value property, and the compiler will now perform flow analysis to inspect the actual state and improve type inference and give you better hints along the way. And maybe you are already using something similar, for example, JetBrans.Annotations to augment your types with additional nullability information. For example, you can use can be null and item can be null attributes to annotate your fields and collections. But unfortunately, there were no attributes for nested collections and composite generics, and attributes aren't allowed everywhere in the language, so you couldn't annotate in this manner local variables, implemented interface, generic type constraints. So now with this feature, you can do all of this. And let's try it. I happened to have a process solution checked out when I prepared this presentation. And I thought that giving the demo in a real world open source big solution you can check out yourself is better than combining some simple example. So let's navigate to Rosin, and there is a method called try get receiver and member. Let me enable nullable reference types for it, and it accepts an expression something like variable.property and extracts its qualifier, which is variable in this case, and is called receiver, and the accessed member, which is in this case property, which puts it as a member. And now when I enabled nullable reference types there, I have a couple of warnings in this method telling me that I cannot convert null literal to non-nullable reference type or about possible null reference assignment. And this happens because as soon as I enabled nullable reference types, all types inside my program are now either nullable, these question marks at the end, or not nullable. And it means that every type I've written before C#8 is now not nullable, and I cannot assign null values to them. So to fix this, I need to annotate this receiver and member out variables, and it will get rid of these false warnings because this method is definitely fine if I pass something without a qualifier or if it's just a method call, and in this case it will return null. So these warnings are fixed. There is a bunch of other warnings telling me that I'm casting the possible nullable variable to a non-nullable object. And actually, I'm only doing so in order to ensure that it will be compared to null by using reference equality. So I don't really care about the nullability of resulting types. So I need to fix it as well. And this is an override. So I'll probably need to annotate the base method here as well, and all other overrides if there are any. And now usages of this method are flagged. There is only one. And there is a warning that I shouldn't dereference the out variable I got from this method, which might be true in some cases, but right now this method is called try get receiver and member. And obviously it either succeeded in receiving both a receiver and member and returns true, or that didn't succeed, and in this case it returns false and nulls. And I need to tell the compiler about it. I can do this with a special annotation. I'll mention it later in my presentation. It's called not null when true. I will add it to both parameters, and obviously I will have to add it to the method I just altered. And now when I check usages, this warning went away, but the compiler now warns me about these variables because on the false branch, they will contain null values, and compiler can't be sure whether I'm going to use them only inside this if statement or maybe outside of it too. So I must make them either nullable or implicitly typed in order to fix this warning. And that's it. We'll do this 100 more times and we'll finish with this one class. And this probably doesn't sound particularly exciting because it's a lot of effort. And this is probably why this type isn't annotated yet, which is quite ironic because the nullable alter type is exactly the type responsible for the data flow analysis, and its sole purpose in the compiler is to keep your code null reference exception free. And it throws null reference exceptions because it isn't annotated because it's too much effort. So I guess now you understand why it's so important to deal correctly with nullable reference types in your solution and why it could take a lot of effort. But before we start exploring other options, let me assure you that there are a couple of options that could help you with nullable reference types. For example, if you're already using JetBrans.Annotations and you enable nullable reference types in your project, all types that you've written before became not nullable, but the information about the actual nullability is still there in the form of attributes. And you can use quick fixes to convert it to actual new syntax and fix all the warnings related to types that were annotated with JetBrans.Annotations. Alternatively, if you aren't using them, you can make everything nullable and use inspections to figure out what can be safely declared as not nullable. For example, here I have a method that returns either an empty string or some file content, and neither an empty string nor file's content are nullable. So it's safe to say that this method actually never returns null. And I can make it not nullable. And this value that is used to hold the return value is also not nullable. And this way I can make initial contract very relaxed, can allow every method to return null, and then figure out where the contract is can be relaxed and become not nullable with inspections. But unfortunately, there is no silver bullet. There are composite generics, not annotated code, complex contracts, and just code too complex to figure out these inspections. So unfortunately, in the end, it's still you who will make the decision about whether something is nullable or not, and it's still a lot of effort. It could be very bad. For example, I found out that null.json library migrated to nullable reference types in a single commit that changed about 170 files and 4,000 lines, which is quite a lot for a project of this size maintained mainly by a single person. So unless you have anything to do for the next release of your product, features, bug fixes, you'll probably don't have time to annotate your full project. So for now, you can, for example, benefit now and annotate everything later to get some limited help with nullable references by enabling only warnings there. And here I have a method creating some blank transaction and filling its fields from the client's information. And as soon as I enable nullable warnings, I haven't even started annotating anything yet. The compiler now warns me that client's address might be null when I'm trying to use it to find the zip code. And you might wonder why the compiler warns me there, because I didn't annotate anything yet, so all my types are still not nullable. And it's actually because I told the compiler so implicitly. By using conditional access to access this property, I, as a software engineer, told the compiler that at this point in the program, client's address might be null. I know about it, that's why I'm checking it. And if in the next if statement I forget about it, the compiler will help me to find out about it. And this is pretty cool because at no initial effort, I haven't started doing anything yet. I found a bug that could be a very real problem. Maybe I just didn't ever have to create transactions with zip code for clients without addresses. And the compiler will notice explicit null assignments, explicit checks for nulls, such as whether it's the comparison with null or conditional access, or actually annotated types. And you might wonder what's the difference from this mode with enabling everything. And the difference is that when I enable nullable reference types in my project completely, all my types become either nullable or not nullable. And it means that the compiler will warn me about assigning null values to them. And I hope you remember that about half of the warnings I got when I tried to annotate a method in Roslyn. And when I enable only nullable warnings, all types in my program are either nullable or oblivious. And oblivious means that the compiler doesn't know anything about it, this type, and it relies on me to teach it how it's safe to use it. So if I'm dereferencing this type, it's okay. I probably know what I'm doing. And if I assign null to this variable, it's again okay. And I can do this. The compiler won't warn me about it. And it will only warn me about something really stupid, like assigning a null variable, a null value to the variable, and then dereference it a couple of lines later. So this could be good if you are using, for example, VS Code without any plugins, but it might not be really good for you if you are using some static analysis tools such as ReSharper, because in this case, you already got all of this out of the box. An alternative approach, if you aren't ready to deal even with the warnings as of now, is to annotate the library and your public API for your customers and colleagues. For example, this is the client interface I've used in the previous example. And right now, it's not really obvious how I can use it. I probably can guess that not both contact phone and contact email are required for any client, but I can figure out which one is required, whether I can send notifications only about some transactions they initiated, or maybe I can just send them some promotional materials. So what can I do to help my colleagues is to enable nullable annotations and tell that every client has its first and last name, not middle name. Contact phone is required, contact email not so much. And they can actually send notifications with just a message, not about any transaction, but this notification might not be created if the client opted out of it. And as of now, there are no additional warnings introduced in my solution, so I don't have to fix anything yet. But if you look at the compiled code, you'll notice there are attributes nullable context and nullable sprinkled all over your interface. And these attributes will be used by the compiler to teach your colleagues how to use your interface in a safer manner, where to expect null values and where not to expect them. Finally, you can enable the analysis only for some parts of your project. For example, you can enable it completely in the CS project by using the nullable tag, and then enable it per file, class, or member with preprocessor directives nullable, enable, disable, restore. So, for example, this is used in use of JSON, where there is a JSON validating reader type with more than 1,000 lines of code, and it's obsolete. It has been moved to its own package, and probably you do have some class types like this in your code base that were written a long time ago by people who are no longer working in your company. It's there for backward compatibility, but no one actually knows what it does anymore and how exactly it works. And you might not want to invest any time into fixing the warnings there, and you definitely don't want to enable nullable reference types and ignore warnings, because in this case, everyone who will have to use this type will think that it never returns nulls, and that might not be true. So you can just disable nullable context there, and you will not get any warnings, you will not get annotations, it will be just a gray area for the compiler. And this is what you might want to do with entity framework models, because this is the problem I encountered in my pet project. I enabled nullable reference types, and the next time I ran my app, my database was migrated to non-nullable columns, because even so nullable reference types don't affect compilation. The information about nullability will still be available by reflection, and some frameworks, such as entity framework, might use it, for example, to generate database columns not nullable for every not nullable property in your model. So you might want to disable nullable context in entity framework models until you figure out when and how you want to annotate them. Or alternatively, you can annotate the code as you write it, and this is actually the approach employed in the compiler. If you open the nullable Volcker type I've mentioned before, you'll notice that there are some methods enclosed in nullable enable, nullable restore region. And this means that recently someone either added this method or modified it, and it enabled nullable reference types for this method only, fixed all the problems there, and this became a safe place where no nullable warnings exist, and the rest of the class is not annotated yet. And the on the plus side, this works because the code you didn't touch is probably okay. You've already wrote it, tested it, delivered it, deployed it, and it already doesn't throw null reference exceptions. You probably don't want to waste your time annotating it. The downside, is that it might take decades to annotate your whole project. For example, the nullable Volcker type has, as of now, only about 600 lines out of more than 9,000 annotated, which is about 7%. And until you finish this process, you can't really trust any API because you don't know whether it's annotated or not. And this is a big problem. So let's figure out how the compiler works with an annotated API. I've checked out the nlog library, which is a reasonably popular login library for .NET, and there is a method called getLogger that accepts loggers' names. And as someone who didn't use this library before, I might assume that name is used, for example, to figure out which lines are added by this particular logger from the log file, or maybe to share the same logger configuration between different types. And if I don't plan to do any of this, I can leave the logger unnamed and pass null there. And I will be wrong. This code will result in a runtime crash, but the compiler will not be able to tell me it because it doesn't know anything about the getLogger type. The library isn't annotated, and it means that the compiler doesn't want to nag me about null values. It just believes me that I'm knowing what I'm doing. And what is actually even worse, that in order to prevent all the warnings from unannotated API in my code, the compiler is forced to consider them not nullable. And you might accidentally see this information while hovering over a variable you got from unannotated API, and the compiler will actually lie to you and say that it is not null here, and that might not be true. So this is quite dangerous, and unfortunately there are lots of not annotated libraries out there. As of now, I've checked top 20 libraries on Nugget.org, and only newts of JSON was fully annotated, and XUnit has taken some steps into this direction by annotating some of them assertions, but even they aren't there yet. So unfortunately, we probably don't get the whole Nugget.org annotated anytime soon because it's a lot of effort. And you might wonder what can we do with unannotated API to be on the safer side. I have a message there with nullable reference types enabled. It accepts some non-nullable value, and that's a major point there because I'm going to dereference it by calling the trim method, and it can return a null value, so it's not safe to use this method's output. The worst case scenario, it doesn't accept null values and it can throw one on me. And I'll add two other functions, one annotated with JetBrans.Annotations, one not annotated at all. And in the real world, they will probably come from either third-party libraries or not annotated parts of your solution. And I will use all three of them. And when I enable nullable reference types, I'll get only warnings about the first one. And that's because the compiler didn't want to add any third-party dependencies, so it only warns you about problems it can be sure of. And you probably will want warnings about the second call as well, and probably even the third one if you want extra safety. And as of now, your only option is to either run some static analysis tool such as resharper side by side with the compiler, or opt out of resharper analysis, and both these options are not really good for you. So for the next version in resharper, we will support our annotations in compiler analysis engine out of the box. So here you'll get compiler warnings for the first call and resharper warnings for the second one. But what about the not annotated API? First, I'm not sure that you would really want warnings about it because it could result in tons of false positives. But if you really want to be really pessimistic about any unannotated API and you really want this extra safety, you can change the analysis mode in resharper settings to pessimistic, and it will consider any API that doesn't have explicitly annotated nullability as not safe to use, and you'll get warnings about it too. So you can guess by now that null safety is just the tip of the iceberg, and there's a lot of other things that you need to know. For example, we've just learned how to deal with unannotated API, but there is much more: generics, complex contracts, and incorrect analysis results you need to know how to deal with. And I found a good example on Twitter. That's a good starting point for all three of these points. And someone was using a function called tryfunc that will return a generic parameter, and on some condition it can return default value and return false there. Sorry for the not descriptive names. Twitter is not really the best place for descriptive names. And the person told there that they already tried annotating the out variable as nullable, and it didn't compile because the compiler can't be sure whether this question mark means nullable struct if I substitute something like int to this type parameter, whether it means nullable reference type if I substitute something like string, And what exactly should it mean if I substitute something that already has an annotation, such as nullable int or nullable string? So to be on the safe side, the compiler just disallows this syntax, and you can't annotate it this way. The question is how to get rid of this warning in this case if you can't annotate the out parameter. And the first answer on Twitter was consider not doing so. The warning is telling you that the caller doesn't expect you to initialize it to default, so consider not doing so. And this is a good advice, not to lie to the compiler, but probably doesn't help you a lot if you are really going to write this function. So there was a second part. If you really need for some reason, you can suppress the nullability warning by using the exclamation mark at the end, and you'll add this single symbol, and it will suppress any nullable warnings on this line. And this will be really bad because imagine that you are this person trying to write this function, and you've already tried a couple of ways to deal with this warning, such as annotating the out parameter. You'll go on Twitter because you have no idea how to suppress this warning. And the first answer is to just get rid of it. And it might be really tempting to just suppress the warning and move on writing some other code. And it will be bad because if you lie to the compiler, it will be not be able to help you later. For example, here I'm using this exact function to get a non-nullable string, and the compiler has no idea that somewhere within this function I've assigned a default value and it's not safe to dereference it. So to figure out the better way to annotate this thing, we need to think of something in the framework with similar behavior. For example, the first default method also returns a generic parameter that might be null, regardless of whether the original collection had nullable elements or not. And if you'll try to write this signature, you'll get exactly the same warning for the default parameter, and exactly the same error if you'll try to annotate the return value. So does it work in the framework? Let's write a test to figure this out. I've created an empty string array with non-nullable strings, called first default on it, and dereferenced the result, and I got a runtime crash without any warnings to the compiler. And it's mostly fine because we are developing the language very fast right now, and sometimes we break things along the way. The warning will actually be there in the .NET 5, which is currently in preview, and we can check what changed between the current version and the preview one, and we'll check this signature. And there is a single bit in .NET 5 preview that isn't there in the current .NET Core 3.1, which tells that the return value may be null by using an attribute. And this attribute tells the compilers that regardless of what was the inferred type of the return value, it might be null and it's not safe to dereference. And there are lots of interesting annotations added to the compiler, and you can access them in System Diagnostics Code Analysis namespace. For example, there is a bunch of annotations telling the compiler where you expect null values and where you don't. For example, allow null and disallow null are used to annotate the equality comparer, and tells that regardless of which type you implement it for, you still should be able to compare values of it with null, and you shouldn't get hash code for nullable values. If you're interested in differences between allow null and maybe null attributes, please check the link below the slide when this recording will be online. There are some other annotations, for example, to tell the compiler about assertions such as does not return if annotating debug assert. And there are a couple explaining complex contracts to the compiler. For example, pass get file name will never return null if you never passed it in. And dictionary try get value is annotated to tell the compilers that regardless of whether the dictionary contains nullable values, its try get value can return a null if it also returned false from this method. I hope you remember the not null when true annotation I've used in Roslyn when I was demoing the future, and this is almost similar, just mirroring attribute telling that something may be null even if it's declared as not nullable. And this is exactly the annotation we need to fix our example. So I can tell the compilers that this out parameter still may be null regardless of whatever is substituted to t if I returned false. And not only does it fix the warning, but now, since I told the compilers that there are two possible outcomes of this method, either it returned false and nulls are allowed, or it returned true and nulls aren't allowed, the compiler actually verifies now that this method complies with this annotation and the output is always correct. And it will now be able to warn me about using the output variable if this method returned false, or if I just ignored the return value and didn't check it at all. But unfortunately, the compiler isn't always right, and sometimes you know something the compiler doesn't. For example, you wrote some code and you checked some condition, and then you called the getValue method with this particular argument, and you just know that under these particular circumstances, this method cannot return null, but you can't express this construct in attributes, so the compiler complains about possible null reference exception. And here you can use again this null suppression warning expression, unofficially called damit operator, to suppress the warning. And I would actually want to warn you against it, because your code is subject to change. If it's not, just forget about the warning, deploy the code, and forget about it. But if it is subject to change, then sooner or later, someone else, probably not you, will modify this code and, for example, change this condition, or maybe remove the invariant you relied upon in the getValue method. And this single exclamation mark is really hard to notice. Even here, when there is just 4 lines of code, it just looks like part of the variable name. And when someone else will be modifying the code in a real project, it's really easy to overlook. So a better way would be to assert that this variable is not nullable. First, because it will be very visible to whoever will modify this method that you don't expect variable to be null, and will force them to think twice whether after this modification it's still true. And second, if for whatever reason this assertion would be broken, you'll still get a descriptive message informing you about the problem, and not some cryptic null reference exception somewhere later in the program. But sometimes you need it. For example, the compiler is wrong. In the commits that migrate newts of JSON to nullable reference types, there are about 200 usages of this operator just to get rid of some false warnings. And for example, if you are writing some ORM model or your type is used for deserialization, you might want to declare a non-nullable property, and there is no initialization of it nowhere in your code because it will happen outside of it, for example, in the ORM framework. And in this case, Entity Framework, for example, recommends you to initialize this variable with null and suppress the warning about it. An alternative approach would be to declare a constructor that will be used by ORM and suppress warnings about not initialized properties in this constructor only, and mark it as obsolete so that no one will accidentally use it and initialize and create an object with incorrect state. And unfortunately, the damit operator also has a dangerous implicit function you probably want to be aware of. And it's not easy to observe, so I've created an example just with this. So let's get back to writing some bank software. And probably you'll want to handle failed transactions at the end of the day in some way. And imagine that there are 2 methods returning with this. Get failed client transactions that return the dictionary of transactions and clients that initiated them. And it can return null if there are no such transactions, just to save some allocations. And there is a second method, get failed automatic transactions, that returns the failed transactions that aren't initiated by any customer, such as commission deductions or interest rates or something like this, originated automatically. And you definitely want to process these too. So first, you need to accumulate them in a single dictionary. So I've created a dictionary of failed transactions. And since I'm going to add automatic transactions into it, I've used nullable reference type for the client and initialized it with client's transaction. And the first thing I get there is a warning that I shouldn't assign a dictionary with non-nullable clients to a dictionary with nullable ones. And you might wonder why this is a problem. The short answer is because value parameter in the dictionary is invariant, and this probably didn't clarify things much. So let's figure out an example where this is the only warning preventing something terrible from happening. So again, I create 2 dictionaries and assign one of them to another with different nullability of their values, and there is exactly the same warning. And now I have 2 references pointing to the same object but they are typed differently. And nothing stops me now from adding a transaction without a client through a reference that allows nullable values into the dictionary, and getting this client back through the reference that assumes that there are no nullable values in this object, and it will allow me to dereference it, and it will result in null reference exception. So this is a cool warning. It helps you with null references. It should be there, but does it apply to our case there? Because right now we are the only owners of this reference, and whatever nullable values we add to it, we'll be able to treat as nullable because it's the only variable we can access, and no one else can observe them. So it should be safe, shouldn't it? And you might want to just suppress this warning, because the only other option would be to create a new dictionary and copy the content of the first one to the new one, and it will just waste CPU time because you'll be creating exactly the same object. So now we suppress the warning because there was nothing wrong with this warning, and I'm going to add automatic transactions to this dictionary as well without clients. And now I have a problem in my code because there is no warning when I dereference this dictionary to add a new transaction into it. Even so, I declared the variable as nullable, and the method is clearly annotated as returning null if there are no failed transactions. And this actually happens because of this diameter break, because there are two functions to it. First, it suppresses the warnings, but second, it tells the compiler that this variable isn't nullable. So if I remove it, I got both warnings back. And this is something you might probably want to remember about this operator whenever you suppress a warning with it, because as in this case, the code that should have a null reference exception warning might not be written yet, or it might be somewhere outside of your screen in the real world tab. And you might inadvertently tell the compiler that something is not nullable while you were trying to suppress some other warning. And this, unfortunately, you need to remember. And by now, you should know how to deal with unannotated APIs, how to deal with generics by annotating them with flow annotations. You should be able to explain complex contracts with them to the compiler, and you know how to suppress warnings from it. So what's next? Next, I will talk about common problems in the analysis and how the future has evolved since its release already and what's planned for the next versions. And finally, I'll give like 2 or 3 minutes to talk about warnings as errors. So let's move on. There are some problems that are quite obvious for any data flow analysis. For example, it won't be able to tell you anything about the code with multi-thread access, ref parameters and variables, not annotated API. And sometimes it's less obvious because some people might not expect that it doesn't work well with cross-procedural dependencies and closures or array initializations. So, for example, here I have a type called slide content, or an app something like PowerPoint, or maybe I want to do a presentation about my failed event transactions and how I handled them. And on this slide, I can post image and text, and there are a couple of columns. And I want to provide a method format content that if both image and text are present, I'll use 2 columns and set image to the first one, text to the second one. And technically, there is no problems in this method. There are no warnings, but actually it will crash with a null reference exception when I'll try to set image to the first column, because set to columns template method actually handled this content, and when it added 2 columns, it moved my content to the first one, and in order not to duplicate the content of my slide, it nullified these properties. But in the format content method, the compiler doesn't know about it. All it knows is that I just checked for null 2 properties, and then I'm using them after some method call, and it has no knowledge that they are already changed. And you should know about it, not because the analysis is bad, it's just fine balance between false positives and false negatives. So the compiler team chose to think that no instance methods can alter the object state. So please don't write these methods, and if you write them, be extra careful with them because the compiler analysis will have some problems there. And obviously, lots of data flow analyzers has problems with closures. For example, if you are using local function or lambda expression to reset some variables to nullable state, the compiler will not be able to pick it up. All it will see was that you are checking some variable for null and then using it, and it could result in runtime crash without any warnings. And also, if you've checked something for null inside, for example, a local function, the compiler will not be able to tell you about this, and it will result in a false warning. This is actually a GitHub issue that I found on Rosten Tracker, so there are lots of people out there who aren't expecting this behavior from the compiler. And obviously, the compiler doesn't know when delegates will be executed in your code, so the best thing you can do is to inspect them at the moment you declared them. And if some variable that it closed upon is changed afterwards, before it was executed, the compiler will not be able to tell you about that. So you'll be able to use some other static analysis tool. For example, ReSharper will warn you about access to modified closure, so please pay attention to warnings like this. And even so, it was less than a year since the feature was released. There are already a ton of changes. You might not expect this much from the feature that was released just last autumn. Implicitly typed variables became nullable. Tracking of generic variables was redesigned. Local functions got call site analysis. Annotations got contract and inheritance verifications. There is a ton of changes. I don't even know how many developers are still working on this feature, and it got updates daily. So when it was released, implicitly typed variables inherited state of the initializer as they type. So for example, here I'm iterating a linked list and its head is definitely not null. So the type of the current variable is inferred to be not nullable, and the compiler used to warn me about assigning nullable values to it. Even so, there is nothing wrong to it, and I was forced to fix this problem by specifying the type explicitly. And it could become cumbersome. Here it's just a list node, but in the real world it could be something like list node from dictionary of my type to immutable array of something else. And it's really a lot of text to put into your program just to add a single question mark. And for a brief moment, var question mark syntax was considered, but right now the compiler team decided that this variable could be nullable, and you can assign nullable values to it just fine. So there will be less warnings in your code, and it will not result in any false positives because the compiler will track its state separately. It will still know that it was originally initialized with a non-nullable state, so it's fine to dereference it until you've reassigned it with something worse. And tracking of generics was redesigned. For example, when the feature was officially released, there were warnings for every default or null literal converted to a generic type, because it was unconstrained and someone can substitute this type with non-nullable reference type, and this assignment would be wrong. But unfortunately, you didn't have any option to annotate this local variable. So in order to reduce the number of false positive warnings there, for example, here there is nothing wrong with this code, because even so I assign default values at some code pass, I'm still checking this variable for null every time before I dereference it. So now there are just no warnings there. And instead, the compiler warns me when I use it incorrectly, or when I assign it to a public field or return from a method because someone else, for example, using generics of non-nullable strings, won't expect me to initialize it to default value. That's the first reason for warning about it. And the second one is that unlike local variables, I actually can annotate fields and return values by using attributes. So the problem was only localized to variables, and it was solved there. And local functions got call site analysis. When the feature was released, the compiler did something pretty simple like this. It saw that there is a closure over the input variable that is nullable, so it can hold null values, and it warned you about using it. But right now, the compiler already does something much smarter. It still sees that there is a closure over the input, but instead of warning you right away, it inspects all calls to this local function and sees that you already assigned to the variable something else, something not nullable, and it should be safe to use. And if for some reason you add another call with different state of the closure variable, the compiler will be able to notice this and tells that at one of the calls, input variable is nullable, so it's not safe to dereference. And again, it will result in more precise analysis with less false positive warnings. And probably one of the reasons why this feature question wasn't answered correctly in the first place is maybe null when false suggestion, is because it didn't work this way when the feature was released. So lots of people tried it and it didn't work out. And actually, you still got warnings for assigning default variables even if you put an attribute there. And now, not only the compiler inspects this attribute and tells that it's fine, but it also inspects the body of this function, and it will warn you if the contract is broken. For example, if I return true with default state in my out parameter. So again, the code becomes this. There are less false warnings in your code, and it becomes safer. And annotations are now checked with respect to inheritance. For example, I could have the string length compare implemented to not nullable strings, and I might think that it's okay because I'm implementing my compare to not nullable strings, so I'm comparing not nullable strings, and it's not really obvious from this signature that actually the equality comparer allows nulls with attributes that I didn't inherit. And now the compiler also verifies me, so I don't verifies the signature, so I don't need to check every interface I implement because it will warn me that the equals method should allow null values and I didn't implement it correctly. So again, more warnings and safer code. And in the future, we are already getting a pair of new annotations for C#9. You can try with preview language version. We are definitely getting more framework API annotated, such as first to default. And there is a consideration for a new syntax to annotate generics. And we will probably get some bugs fixed and improved closure tracking, especially for local functions. I think there is some work done about that, but I can't be sure because it wasn't announced. So a new annotation added to .NET 5 and that will be available in C#9 is member not null on a method. I actually used it in one of my previous examples, and you could notice that columns type is declared as nullable, and I'm using it without any null check. And that happens because I've already called set2columns template method, and it is annotated with a new annotation, member not null columns. And it says the compiler that whenever I call this method is guaranteed to initialize the columns property, and it's safe to reference it after that. You can add also annotation member not null when to annotate something like an is valid call and tells that if it returned true, you won't have any warnings when you try to dereference one of the properties. And it can be used to solve one of the pain points reported to Roslyn, because Roslyn now checks whether you've initialized all your nullable, not nullable fields and properties in your constructor, but it can only check code inside the constructor. And it does not have any knowledge about methods called from this constructor. And so in this example, the compiler warns me about not properly initializing the second variable. And I can tell the compiler that it's fine by adding this annotation. And it will pick it up in the constructor and will realize that I actually initialized both fields. And it will also check that the init method actually initializes the property it promised to initialize. So it will be very safe. And in the future, there is a consideration for some new syntax for generics. For example, here in the first default signature, we kind of worked around this problem by using the maybe null flow annotation. But unfortunately, it didn't exactly solve the problem. It just moved it to the other way, level. So here, there is the signature of where method. And there is nothing in this signature that could hint the compiler that the resulting sequence won't contain any nullable elements if I filtered it out by using where something is not null. And I could try to solve it by providing a where not null method that actually exists in Kotlin, which is other language with nullable reference types. But unfortunately, I can't annotate the type of elements of this collection as nullable because the syntax isn't allowed. And I can't fix it with attributes because attributes are about top-level nullability. So in this case, this method will allow nullable enumerables, but it won't tell anything about the type of elements. And in the future, there is still a discussion about what exact syntax will be used, but it could be something like this with double question mark. And in this case, I will be able to tell the compiler that this method will filter out any nullable values from this collection, and it will be safe to use after that. And after that, probably we'll get again tracking of generic variables redesign, because the main reason to change them was the inability to annotate them in any meaningful way. And finally, I've seen lots of people thinking that warnings as errors will save the code from null reference exceptions. They need just to enable this feature, and it will keep the code completely clean. And if they enforce it as errors, they will never ever see again a null reference exception. I hope that I've already assured you that it might not be the case, but let's discuss it. There is a new nice syntax for it, warnings as errors nullable, that will leave to errors any nullable error warnings, not even existing now, but that once will be added in the future versions of the compiler. And it will indeed easy to spot regressions and reference that assembly's API changes if they are annotated or as they are annotated. But the downsides are that language changes will break compilation, refactorings will often break compilation. Sometimes you won't be able to declare a variable you want because it will be not nullable, and you are risking boggling your code with David operators or redundant checks just to satisfy the compiler. So there is a couple of examples I found out on Roslin's GitHub issues. First of all, remember this simple change: implicitly typed variables became nullable. And I mentioned that its primary goal was to reduce the number of warnings in your code, but even it is a breaking change if you are using warnings as errors, because sometimes the actual nullability of the variable is visible, for example, when type inference is done for ref arguments, and this code used to compile when the feature was released, and now since May it doesn't because the language changed. And this is an issue reported by ASP.NET Core team on GitHub when they tried warnings as errors on their solutions. And they had two variables that could be either nullable or not nullable. They checked whether they both are nulls, whether they both are not nulls. And we as software engineers understand that there are just two variables. Both of them can be either nullable or not nullable. So there are just two bits of information, and there are just four possible outcomes. And we definitely know that in the fallback branch, the variable number 2 is not nullable, and it's safe to be referenced. But the compiler doesn't think in terms like this. All the compiler sees is that there is just variable number 2, and it's declared as nullable, and I'm dereferencing it without any proper null check, so I should get a warning, which was lifted to error in this particular case. And refactorings will often break code as well, because, for example, you are checking some nullable field, and you know that it doesn't contain null right now. So you are doing something with it, and this code grew large, and you wanted to extract it in a separate method, so you do it. And now the compiler doesn't know that you only call this method when this field is not nullable. And it emits a warning, which is lifted to error in this case, and you are forced either to suppress it or to extract this method along with the null check prior to it. And sometimes even as simple refactorings as extracting a variable could be break and change. For example, here there is an example again from GitHub when someone used conditional access to use property named b and type check it for some type. And the compiler is actually quite smart there. It realizes that either variable a was nullable, and it returned something that didn't pass the type check, and the if statement will not be executed, or it was not nullable, returned something that could theoretically pass the type check, and it's safe to use, so it allows it. And as soon as I extract a variable from it, instead of a simple if statement that the compiler can process, there is now an implicit dependency between two variables, and this is already too complex. So it reports a potential nullable dereference warning, which is false in this case, and your code is broken. And there is a tweet by someone who actually tried to use warnings as errors. And for example, here they were surprised that when inspecting one of the methods in XML project builder type, the compiler didn't know that they already assigned something not nullable to one of the properties, because the compiler doesn't inspect the constructor when it checks other members, and it definitely doesn't know whether any other functions can alter this property. So just to be on the safe side, it reports possible dereference of null reference to anything that can theoretically be nullable, and that could be surprising sometimes. And finally, sometimes you can't declare a variable of nullable type, because, for example, in pattern matching, you'll have to use not nullable type to avoid some syntax ambiguities. And this means that you can't assign nullable values to this variable later. And you don't want to suppress this warning, because you will also tell the compilers that this variable is not nullable, as you remember, and this might not be true. So in order to correctly declare a nullable variable, you'll be forced to create a second variable with different nullability, assign the first one to it, and use the second variable, which could be cumbersome. So to sum it up, please don't lie to the compiler and don't overuse the diamond operator. And also don't trust the analyzers blindly, because at the end of the day, it's just another analyzers engine with its own downsides and sets of assumptions. And please help it with well-typed API and use flow annotations if needed. And treat its warnings as a nudge to look closer at some codes that could potentially be problematic. It will be easier to spot such problems, but still, at the end of the day, if you think that something is probably okay, it probably is. And there are just some codes that could confuse the compiler. Simply the warnings serves worth it for you, because it could make your code a little too brittle, but it will definitely save you some time on checking some possible null reference warnings. And choose whether you want to enable the full feature. There will be just a few problems with unannotated API. Help is on the way if you are using other static analysis tools such as ReSharper. Whether you just want to enable warnings only, because in this case, at no initial effort, you'll get some bugs code. And unfortunately, it might not offer much benefits if you are already using some other analyzers, or whether you are not ready to deal with any warnings and you can want to just use new syntax and annotate your API for colleagues. And in this case, you want to enable annotations only. You can enable it on the full project at an enormous initial effort, and inspections and fixes might help a bit. Or you can do it step by step with preprocessor directives, Nullable, and it can take a lot of time, and unfortunately you can't trust API until it's finished. But you will be annotating your code at your own pace while changing the code base, so it will probably be much less effort. Or alternatively, you can annotate batches of files related to a single feature and make a single feature within your project null safe, and then think whether it's worth to annotate the next one. And please remember to use daemon operator carefully and use flow annotations to tell the compiler about possible problems in your code and how to inspect it to help it understand your complex contracts and assertions. Thank you for your time. If you have any questions, I will be glad to answer them.
All right, Andre, thank you for a very interesting session. Really cool to see all of that and all of the edge cases as well. There is one question from Victor, and he's asking if there's a possibility on replacing ReSharper annotations with nullable types in your application.
Yes, I actually had a slide about it. There is no possibility right now, but we are going to add this feature hopefully in 2020.2. It's already prototyped. I'm not sure whether it's merged and available in the latest YAP, but hopefully it will be available in a couple of months in the next version. Let me demonstrate this slide actually. It was somewhere there. Yeah, so basically you'll have something like this with ReSharper annotations grayed out and a quick fix to move them into the type syntax, and you will be able to do this in a method, file, project, or solution. So we are working on it.
Cool, thank you. Another question is whether you recommend enabling warnings as errors on new projects that you create.
It really depends on whether you want this extra safety, and it really depends on what type of project you are doing. For example, if you are doing something related to rocket science, and if some null reference exception could lead to an explosion, you'll definitely want this extra safety to think twice about every code that could result in a null reference exception. But if you are just doing some simple website, for example, and you've just tested the most common scenarios, and if it will throw a null reference exception in some corner case, it's not a big deal. You can just log it and fix it later. It might be make your code a little brittle, especially considering because all the language changes that are coming on, because the future isn't finalized yet, and future changes might break the code as well as refactoring. So you might end up wasting too much time on annotating everything and fighting with the warnings, while you would like just to ignore them when, for example, the analyzers got it wrong. So it's unfortunately just a balance of effort and profit, and it's up to you for every project.
Like I used to say in my consulting days, it depends.
I personally won't recommend using it straight away. You can try it on some projects, for example, on your infrastructure project, to see how bad it could be, or maybe in something that didn't change much, for example, some helper util types that you write once and that should work everywhere in your project. And in this case, you want this extra safety because you're not going to refactor it very often.